all the aspects and are present here. So myself, Sarkar, Department of Computer Science and Engineering, Tripura University. Today I'm going to present my public seminar, and the title of the topic is Design and Analysis of Intelligent Recommendation System for Tourism. So this is the table of content of my public seminar today. The research objective, what I performed under objectives, introduction, literature survey, then multiple algorithm, PWT algorithm, G2 algorithm, and after that I will conclude my thesis works. So first of all, I will share my research objective. So unlike previous approaches, like existing approaches, which only give a single itinerary. So I will show you later on what is single itinerary exactly is. So and tourists can visit a new type of UI in a previously unexplored location by following the sequence of itineraries. So in these works, we are totally focused on multiple itineraries or sequence of itineraries, and also to recommend a sequence of itineraries by considering detailed aspects of each UI. So UI means suppose if you want to travel some place in US. So suppose some place from Tripura, suppose to check the place. So that will be my point of interest. So point of interest is different based on your interest. Okay? Maybe you are more interested in park, maybe you are more interested in at museum. So it depends person to person, or I can say man to man. So we are going to focus detailed aspects of each UI and develop algorithm to suggest a sequence of itineraries in order to meet a number of communities' interest of a group of tourists. And that also I am going to cover that is this group recommendation system. So throughout my PhD work, this is summary of overview of my publication of work. You can see that surveyed the existing works. I have surveyed before I going to start my first objective. I surveyed the existing work which is already there in the literature. So you can see that is published, accepted in multimedia tools and application. Then multi-tool concept, which is published in expert system with application. And after that, my second semester progress report, I have prepared PWP algorithm. That paper also already accepted in expert system with application. Then you can see that another paper, that is third semester progress report, I have shown that we have submitted to new generation computing. Next, excuse me, sir. Okay, so the fourth semester progress report, you can see that multiple itineraries based on UI visit time I have prepared, and that is accepted. And you can see my fifth semester progress report. I have shown G2 algorithm, multiple itinerary combinations.
Slides are not moving. Slides are not moving. Slides are not moving.
What is not?
Slides are not moving.
Okay, so I can share here.
This is the example.
I think now it is okay. Yes. So this is the overview of my G2 algorithm. So that online or the presenter maybe they have not covered this. So just I going to backward just. So it is work performed under objective, sir. I did this survey of existing works. After that multi-tool algorithm. Then second semester progress report. This is the summary of my work. I have some of the paper published in journals and conferences as well. You can see that this is my fifth semester progress report. Okay, after this I think it is okay. So now from here we can start. It is introduction. So in introduction, I can as far as my work, I focused basically my focus on tourism recommendation system. Actually, tourism recommendation system provides suggestion to the tourist to identify the most suited transport, accommodation, and other items. And due to the sake of simplicity, I have not mentioned all the items, but we have a lot of items. So you can know that now we are here from the morning. That is our interest is there at university, some education center, where we are more interested of that. So based on that, our interest will be optimized, or I can say the customer. So also you can see some of the point of interest UI is a specific point location. Someone may find useful or interesting. So personalized travel package with multi-point of interest recommendation, you can see that there are a lot of point of interest are here, lot of POIs are there, lot of POI, because in the city of Agartala, we can see that lots of POIs are available in city of Agartala. If you consider the Chantal Valleys, maybe we can consider Jagannath Temple or next, etc. and so on. So like that way, my POI sequence is like that. But what is the problem here? Our problem is we need to complete. Please listen on the focus. Please don't stop. So you can see that a lot of POIs are there. So one POI should be connected with another POI, and that is very important because I cannot give you suppose 6 POI randomly. It is not possible. If I give you 5 to 6 POI to you, that should recommend and that should be complete within a specific time period, and not only the time period as well as cost also. Maybe you forget, maybe suppose 1,000 rupees are there. Within that 1,000 rupees, your itinerary should be complete. So your system can recommend more than 1,000 rupees, then you can like for that. So as far as recommendation, our system should recommend to us. So this is all about your personal travel package with multi-itinerary recommendation. So this I have prepared. You can see that what is my objective here. The existing technique you can see there. It is all about single itinerary technique. Okay, it is already published. What are there already before my work? All are single itinerary technique. What is single itinerary? You can see these are all are POI. This POI may be Ujjain Valleys, maybe one POI, maybe Sipai Jagan. Okay. So like that, lot of POIs are there. Maybe movie hall or maybe anything. Okay. So this is called single itinerary. But in our case, we have considered the concept of multiple itineraries. So suppose it is obvious that if you want to go suppose place like USA, it is obvious that I need to stay at least more than 1 day, maybe 2 days or 3 days. At that time, multi-itinerary concept is very much essential because my algorithm cannot be run suppose today and then again I run my algorithm. So then my itinerary should not be connected. Okay, if I consider the system, so itinerary should be connected. So that's why the system should recommend a set of itineraries in a single way. Okay, suppose today if you run the algorithm, your system should give you a sequence of itineraries. So that's why you can prepare that itinerary accordingly. You can prepare your budget accordingly or book your flight or ticket accordingly. So that's why multiple itineraries is very important concept that we have considered here. So this is the difference between single itinerary and multiple itinerary. So next, I started some of the literature work, and this is the motivation of my work. You can see that distribution of tourism recommendation systems article by years. So you can see from 1992 up to 2020, you can see the graph of tourism industry. So how the graph is going? That how many research papers are published? You can see that almost it is more than 500. This is the database based on the Web of Science. Maybe other indexes are there. You can search it for that. More than 1,000 papers are available. So this is very important sector we have covered here. So another and some of the parameters. Okay, this is also important because I should recommend my system based on some parameter. Your parameter may be interest. Your parameter may be popularity. Maybe traveling time. Maybe transport. Or lot of sectors are there. I have already covered this sector. So suppose some of the sectors you can see 12%, some of the sector 2%. That already has covered in the literature survey. So after that, this is some of the literature survey I have mentioned here. That is the et al. Recommends the most interesting location according to the predicted categories. So what are the categories here? I have not mentioned because suppose you are suppose Ujjain Valleys. Okay, so Ujjain Valleys comes under temple category. Okay, suppose if you want to visit one, suppose I can say that one food or something, food plaza or whatever it is, or Domino's, that comes under suppose suppose food category. So like that, or you can say restaurant category. So like that, we can categorize our point of interest. So they have considered 4-dimensional static tensor, time decay factor by calculating the difference between the two successive checking, and we have find some shortcoming also, complex model wherein every calculation uses all the check-ins data, and in case of new user included in the RS, the performance is performance degraded. So that we have find out. And also you can see that Lee et al. Developed partial algorithm, which is very fast algorithm they have designed, like partial algorithm that is considered personalized your recommendation system based on geotech photos. And this is very important paper in case of tourism industry, I can say. So there also we can find some demerit of this, like geotech photograph, like arrival and departure is very difficult to calculate properly, and in et al. Mining the trajectory pattern which are frequently visited using user connection. In a single way, the trajectory of a train is also a single itinerary because these all records are specifically designed for single itinerary. The pure recommendation made are not at all diverse in nature. So being able to propose a time-aware metric embedding algorithm, wherein the factor of user visiting attraction at different point of time is taken into consideration. This approach is different dynamic approach because various point of view they are considered, various point, and with respect to specific timeline. And shortcoming the link between a particular season of the year and specific attraction has not been done appropriately. Apart from that, you can see new address suggests the best possibility within the constraints of the travel of time of tourist, and then the same you can see the same disadvantage we have identified here. And this is all about my marketing algorithm. You can see this is my first one, which I already published in e-commerce journal and multi-touch algorithm. So what is multi-touch algorithm is? This is my system framework. You can see there. So I'll describe what is the local and repository and global included. I will not focus here right now. You can see, suppose think about it is some database. Okay, we have some predefined database, and after that we have calculated. Suppose local is different, global is different. Okay, and after that we find the matching between local and global based on the cosine similarity technique, and we can identify the similar global users. And you can see that itinerary 1, itinerary 2, itinerary n like that we recommend, and it just redirects based on the sum of the parameters are there like time-based user interest, popularity of an itinerary, traveling cost, and we have used multi-tour algorithm here. And after that you can see that itinerary recommendation technique because our goal is like itinerary 1, 2, 3 like a sequence of itinerary. So this is our goal. So I will describe what is multi-tour algorithm exactly is. You can see that multi-tour algorithm is the first kind that recommends a sequence of itineraries because this is our objective, multiple itineraries. Multi-tour algorithm provides the tourist an opportunity to visit a new type of POI. So this is very important. Suppose this is over here. Suppose if you want to go to a place like Hong Kong, because we have not visited earlier, so it's very difficult to find some place which is my interest level. So very difficult to find some place from Hong Kong. So that's why I have written here new type of POI where I have not visited earlier. And the proposed algorithm is based on two types of user, namely local and global user. So what is local and global user concept is, I will tell you like that based on these figures. You can see that suppose I am in Tripura, I have written Delhi here. Just suppose I am in Tripura, I want to go Osaka. Okay, this is my problem state. I am in Tripura, I want to go Osaka. So the people of Tripura is the local user. So we are the local user. Okay, so if I want to go Osaka, then the people of Osaka, okay, is respect to is the global user with respect to me. So this is the difference between local and global user. So for the time of simplicity, for the sake of simplicity, I'll tell you that the Tripura user is the local user and Osaka people are the global user. Okay. So now we have considered this local and global user here. After that, you can see we have calculated the that visit time or average visit duration. Okay, so why average visit duration? Suppose if I stay my university from morning to up to evening, okay, so that means I have some interest. If it is like regularly I have visited some place, then that means I have some interest. So to focus on the interest calculation, to focus on the particular interest of a particular place, we have calculated the average visit duration based on that. And you can see that this TJD, these two factors are considered as a D means it is departure time and it is arrival time. Suppose my arrival time is suppose morning 9 to 10 and my departure time is 4 p.m. So now you can calculate the time in between. So accordingly you can find the interest. Okay. So it does not depend on single, okay? It should be multiple days. Because suppose if you want to go in place today, maybe that place is not suitable for me. Okay. So that's why we need to do some average for that. So then only it will be more related to my interest level. So after that, I have calculated my interest of particular user. We can see that particular user for particular category, and it is very important. Suppose if I focus on restaurant, how much interest are there in particular restaurant? So this is all about my interest calculation. Same things is here. You can see that departure time, arrival time, and this is the average visit duration. Okay. So fine. So after that, we have calculated this itinerary interest and also we have calculated the popularity of an itinerary. What the popularity is, suppose if I want to visit a place like Agra, and suppose I visited only one time, okay? You know, one time I cannot say that Agra is like, my interest is there in Agra. If I visited suppose 4 days, 4 times, 5 times, 6 times, that indicates that yes, some interest is there in Agra or maybe in Agra category. That's why we are calculated the popularity of itineraries, and also the very important factor, traveling cost is calculated in terms of the total physical distance covered by the tourist in an entire tour. Suppose if I going to travel, suppose place like Hyderabad, we need to calculate the distance in between. It is very important because I cannot calculate the time because you can secure time based on the flight move. You take a flight move, maybe air, maybe flight, maybe train or bus, the time can be minimized. But what about the distance? So distance exists, right? So that's why our main focus is traveling cost calculation based on the physical distance. This is the first time we have proposed this technique based on the physical distance covered by the tourist in an entire tour. So this is all about the parameters I have used in multi-tour algorithm, and this is my problem definition. I want to this alpha. You can see that this is alpha weightage parameter IY interest. This is my interest calculation. I have already discussed about that, and this is popularity. These two functions should be maximized, and this cost should be minimized. And this is our weight parameters. I can say that. Suppose if my number alpha is equals to 1, that means I only consider the interest, not only the popularity. If my alpha is 0.5, that means that is the balanced optimization or balanced weightage approach. I can say that. Suppose popularity also there as well as interest is also there. So right, and these calculations are all like itinerary formulation. We have calculated the itinerary, we have formalized the itinerary, performed the itinerary based on this calculation. So like that, our goal is to maximize this function. This function I have already we have found. I have found from the previous slides. From this, lot of itineraries are there, interest are there, popularity are there, and cost is there. So we have to maximize this function. This is our objective. So we cannot directly maximize. Okay, suppose if I give you a random number, suppose I cannot directly tell that I can maximize this or minimize this unless there are some constraint. Okay, so there are a lot of factors are there that need to be considered. Suppose your itinerary should be connected. This is very important things. And that itinerary cannot be visited more than one. Suppose if I tell you, suppose today you have visited suppose Agra, next day I cannot recommend you same place Agra. Then you will be hated. Okay, you just shut down your system. That is not possible. So this is all about my constraints. Okay, so you can see that for this all about. I have found that our algorithm is NP-hard problem. This can't be solved in a collinear time because lot of factors are there. So that's why my problem definition is NP-hard problem. So multi-tour algorithm uses the Monte Carlo research algorithm. So that is very popular algorithm based on the reinforcement learning algorithm. So we machine learning. So that algorithm we have used here Monte Carlo research approach. So some of the factors are there for Monte Carlo MCTS approach: selection, expansion, simulation, and breadth propagation. So these all the factors I have considered in my multi-tour algorithm. And after that, I have found some better results. So to use this, our algorithm to Monte Carlo research approach, we need to calculate the UCT calculation, that upper confidence bound. So you can see that there are these factors are already there. It is already there. But what is there? But I cannot directly use this equation to my tourism recommendation problem because tourism recommendation is very diverse in nature. That we need to calculate the reward, we need to calculate the visited count. So a lot of factors are there. So what is reward we have calculated? You can see that. So this is all about my UCT. So I have designed my UCT of multi-tour like that. You can see interest, popularity, divided by cost. Then reward already I discussed in the previous slide. Then this factor. So exploration nodes can be controlled using. So exploration is very, very important. I just explore my algorithm in the searching of the. So like that, the value of C I have considered as root over 1 by 2. This is already defined. Okay. So like that way, reward also I have calculated interest plus popularity and also the cost. So like that, I have considered some of the real life evolution, tour return, tour precision, and tour F1 score. So these 3 parameters and analyze mean absolute error. I mean, this these four parameters I have considered here. So this is all about my simulation parameter. You can see that algorithm is run both local and global data set because we have two data sets. One is local user, another is global user. Okay. After that, from the local user, we have identified some of the users. So we target some of the user. Okay. And particular user, I need to calculate I need to find out the global users from the user. What I already said. So from the Osaka, that means I need to find some, some people who are there in the interest level, who are managing the interest level. So that's why you can see that our data set is run both the local and global data set simultaneously. So this is the challenge of my algorithm. Because sometimes it may not balance or algorithm globally. So this is all about these parameters. So I have considered some of the baseline approaches. You can see there, Genier, GPOP, these all are very popular algorithms in the tourism industry. Then Tourist, UBCF, Pastor, these algorithms I have considered in my baseline algorithms. So after this data set we have designed, you can download the video. Okay, it is publicly available. This Osaka, Edinburgh, Perth, Budapest, Delhi, Vienna. Okay, number of users, UI visit, travel sequences. This is collected by Flickr and common data set. Okay, if I share my data in the Flickr, so I will be one user. So the data also available. It depends on the user. If you have not shared, then we can do it. So if the particular user who can share that data, otherwise our system can be good. Okay, so this is the description. So like that way, I have calculated my precision table. You can see that our multi-door algorithm outperforms with respect to some other algorithm. You can see multi-door algorithm outperforms based on the precision metrics. So like that way, I just calculate the recall metric also. We have seen that multi-door algorithm outperforms based on other baseline algorithms. So this is my F1 score. So F1 score is just like balance between recall and precision. Okay, we need to check it. Suppose if my recall is fine, now precision is not going well. So we need to balance between recall and precision. That's why you have calculated the F1 score. So after that, this is all about some graphical representation because due to these slides, the representations of it, so that graph is not showing well, but it is different because if I show my full view of slide, then it is properly visible. Okay, so these all are like my algorithm. You can see that multi-door algorithm. Do it, sir, again. The setting I can't share.
No, that's perfect.
Okay. You see, if I zoom it, then it is properly visible. So this is all about my, you can see that multi-door approaches is like better than other, other baseline algorithm. Okay. So I think it is okay. One. Okay. So this is yes, conclusion. My proposed multi-door problem is modeled as the variant of the orienting problem, and the proposed algorithm maximize the user interaction, popularity, and minimize the travelling cost, which is very important for us. And also the proposed algorithm we have used multi-color research approach, which is very important. Algorithm here I already discussed about that. Okay, fine. So this is all about my multi-door algorithm. So even next one, we have designed a technique. It is called PWP algorithm. PWP algorithm is we have focused point of interest within point of interest. Okay. So why point of interest within point of interest? Suppose if I tell you a place, suppose Puri temple. Okay, Puri temple. So everyone know about Puri. How much students you have visited Puri? Puri is no. Okay. Suppose if we visited Puri. Puri, there are a lot of places are there. Why it is famous? Because famous Jagannath temple are there. So existence technique only recommends Jagannath temple. Because Jagannath temple is there. But what about that Puri beach? Our system can recommend. So that's why our system should recommend not only for temple as well as beach also. So that's why our technique should recommend point of interest within point of interest. So suppose Puri has a point of interest. What is there inside? So inside suppose beach is there. Maybe Sagarwan is there, or maybe some other places are there. So that means our point should recommend what is there inside Puri. That objective we have worked there, and that performance for it, we have got the better results based on the existing names. Okay. So you can see, so I have this technique. You can see that your famous Jagannath temple. What I already covered, already it is there. So restaurants already I have covered these slides. I think so. Yes, so this is all about my PWP algorithm. Same case, Now, we recommend point of interest within point of interest. So what is the challenges here? We can't tell you that this is my PY. Okay. Because in my data set, only point of interest are there. Okay. But I cannot directly use my data set in my algorithm because there are only the information about point of interest. But what is the point of interest within point of interest? So that's why we need to change our data set. We need to, prepare our data set accordingly. So like that, we have designed our algorithm and we have used NSGA2 based algorithm, which is very popular. You also know that the NSGA2 algorithm, and we got the better results, and we have proposed PWP itinerary recommendation technique. So, so that I already discussed. Same fashion I have calculated the average busy duration like multi-tour algorithm. So like interest also so it looks like same, but it is not exactly same because multi-tour is just like at only point. Okay, it is point within point. So look like same, but it is not exactly same. You can directly run the algorithm on the top of multi-tour algorithm. Okay, we need to modify something. So after that, with interest same and yes, you can see our problem definition is totally changed here. You can see lot of places are there inside. Okay, interest and interest dash. Interest is my local user. Okay, local user interest. Suppose I am from Tripura. Okay, I have some interest on temple. That is maybe our system can recommend Puri also because it is match. My temple with Puri temple. Okay, so if I recommend suppose my temple with restaurant, just can't be possible. So that's why that's match. So if it is minus means if it is suppose your value is 5 and it is suppose 4. 5 minus 4. How much? 5 minus 4 is 1. So that means we can balance like that. Okay. So look up. So if it is less than the value, okay, there I can say that that matching is more efficient in this time. So for that we have designed our problem definition. So we have also considered some of the weightage parameter. You can see that alpha, beta, and we also classify the weightage parameter based on several factors. I will show you after that. And this is all about my itinerary recommendation technique, recommendation equations. So like that way, I have calculated my weightage parameter. This is interest of particular category, and interest of you can see that it is CI and it is CJ. Okay, that is interest of particular category, and I need to how other user also I need to check. They have visually how much interest there. So that the normalization is very important. That's why I was saying that. So. So like that way you can see LS same manner. Our main focus is like minimize the function of LS and minimize the T cost. Why minimize? There is minus factor are there. I need to reduce the function. Then only my results is good, not maximize. It is very important. So and minimization of my cost function. So this is all about constant are same. You can see that we have used NSGA algorithm. Okay. After that, same parameter we have used here. Our algorithm also run in both local and global user. After that, you can see this is the baseline algorithm I have used. So this is that you can see that PY attraction DC. Earlier data set it is different. It is PY DC. Now it is PY attraction DC. Okay, why PY attraction? Point of interest within point of interest. The particular point of interest which are there within the PY that I call as a PY attraction. I think it is fine. So after that, I have prepared the precision, precision test. We got the better results based on the baseline algorithm. Same case in case of recall F1 score also. So proposed PW problem is modeled as a variant of orienting problem. You can see that also maximize the interest, popularity maximization, and also minimize the traveling cost. We have used energy algorithm. Okay. So next, I will going to cover my third one, which is the last one. It is called G2 algorithm. Okay. So now the question is, G2 algorithm is very important because you can see that G2 algorithm is very important. Why G2 algorithm is important? You can see that I have several groups. Okay. Group 1, Group 2, Group 3, Group 4 like that. Okay. Suppose if I tell you I want to go a place like USA, it is obvious that I need to go at least more than one member. Maybe your father, maybe your mother, okay, maybe your sister and brother. Okay, so we need to go a place like USA. Suppose with my student, I can't go alone. Then then it is not possible sometimes. If you have personal loss, then it's different. But if you want to travel USA, you should go, traveling together. We can travel together. So that is we can call it group-based recommendation system. Okay, so now the question is to recommend a group, recommend to whom? It is particular group, and what to recommend? It is very important. Okay. Suppose you cannot directly recommend because in a group, suppose now 42 members are there. For example, suppose 20 members are there. You have suppose one place, suppose restaurant. You interest is suppose temple. You interest suppose different categories. I cannot tell you that yes, if I should recommend. So that does not match with maybe other members. So we need to please other members also, not only myself. 4 members are there. We need to please each and every member from my group. That is very important. So how to please each and every member? How to satisfy? So this is our objective here. So based on that, we have calculated our, you can see this is my overall, framework of group-based recommendation. This is tourist history of visit, local user group, similar user group. Now I cannot tell you that only local user because now we can go in a group. We cannot go alone in the US. So that's why local user group as well as global user group, I need to get to it. I need to group it. So how to group it? Based on the cosine similarity. Or maybe some similarity functions are already there. Okay. Like that we can get to it. Based on that, suppose 5% they have similarity, we can do it. Okay. So overall, our target is itinerary calculation. So this is our problem definition. You can see the same manner. My target is interest should be maximized, popularity should be maximized, and cost should be minimized. 1 minute. So this is all about. I have already discussed the same fashion. You can see it's the same thing. Yes. So you can. Yes. So you can see this slide. You can see this is a football match. Okay. You can see. So maybe he is the loser, okay? That person is the loser, okay? So this is obvious because 2 teams are there. One is 11 members, another team has 11 members. So one team need to be win. One team has to win. So in football, match is very interesting. So that's why I have added here. So how to recommend this? So that's why if I tell you that we want to play a game which is like a football match or football game. So now we can think about game also. Okay. So what about the game theory? So that's why the concept is here. We have motivated from the famous algorithm, Nash algorithm of game theory. We have used the game theory technique. You can see that. That means I have 5 members. So we 5 members play a game each other. Okay. Suppose this row. Suppose we are playing a game. Suppose a game is like cricket. So one is suppose batsman, another is bowler. So suppose one player should be suppose your mind should be there. Suppose I need to play a game, so I need to win. So bowler think that I need to be win. Okay, so like this mutual understanding like this thing, and the game should be like overhead. Because if I bowl a swing ball, that means you need to understand that bowler is play a swing ball. Okay, if I like this swing, the bowler need to understand exactly like. Cricket also. So like that way, I need to play a game with other members. Okay. So like that, you can see that I have designed my problem statement based on the game theory. You can see that lot of players are there. Only I have discussed. Suppose in game theory, maybe a number of players are there. We can confirm it. Okay. Maybe a number of members, but it is not always possible because even members is limited always. Maybe 10, 12, or 50. It can be like a number. But for the algorithm, we need to restrict our algorithm. That need to be converted sometime. So that's why you can see that player 1 and player 2. Player 1 has 3 strategies. S1, S2, and S3. What is the strategy here? Suppose that player 1 tell you that I want to go Agra. Okay. Player 1 tell you that I want to go suppose Jama Masjid, and he want to go restaurant also. This S1, S2, S3 I can tell you their categories. Their categories I can mention here as a strategy of game theory, because strategy is very important. If you play a game, maybe it is a 6 or 4, you need to have a proper strategy, otherwise you can't do that. Okay, so it is very important. So that's why you can see player 2 also here and player 2 follow. What player 1 strategy? So player 2, suppose he is a batsman, he will follow that player 1 play S1, that means in swing form, or S1. Accordingly, he chooses his strategy S4, S5, and S6. So this is the overall strategy in our algorithm we have used here. Okay. So I think you have understood that correctly. And this is my recall precision and advanced score. Actually, lot of other calculations are already there, also there, which is there in my paper. I have not mentioned for the shape of synthesis. So like you can see there, this is the parameters I have considered here. This is the same. We have run our algorithm global data set, and also Genia is all based on I have calculated. This is the my database detail. You can see Sarkar part of the Delhi winner, and we got the better results when I have applied in case of my decision calculation. You can see our proposed detour algorithm performs better. We have all other results are also there, but for this simplicity, I have only put some of the results. Okay, so this is my F1 score calculation. So the proposed model is a gradient of orienting problem. We have calculated G2 algorithm, vehicle maintenance, popularity, cost, and other factors are also considered here, and recommends a sequence of maintenance is really important. Okay. So this is it. So what is in our future? This is very important because because it is very important. So we need to modify our work in future. So in future, we want to indicate when a PY belongs to more than one category. I tell you that Jagannath is a single category, but what if it is more than one category? Because inside Jagannath temple, maybe some other categories are already there. So this is the way we can work in future. So and another important things you can see. Yes, this is my conclusion, overall thesis conclusion, which I have already covered. You can see. Yes, tourism 4.0. You can see that this is one of the very important projects in case of tourism. We can work based on the tourism 4.0. It is very important project. Okay, the websites are already available, so we can see that, we can use that one, we can adopt their technique. Okay, we can develop our technique and share with them. Like that, we can develop the impact of industry 4.0. And nowadays, what is important? What is very important is that suppose I frankly tell you that suppose design the algorithm. Suppose design the algorithm, and also suppose design the algorithm, and also suppose these publish research paper. Do not put it in case of industry. This is very important. Suppose I design the algorithm and publish the research paper in high impact journal, it does not reflect that the performance will in the industry also. That means we need to be customized. So customization is very important in our algorithm. We cannot directly use in our industry. So that's why this use some of the future work here. So that's why actually to work properly with the industry, we have already applied a project, ICT-based project, that is already approved. We are working on that ICT-based project. It is based on tourism. Okay, it is already funded by ICT. We are working on that. So what I told you earlier, that we are trying to go in the in the practical as well scenarios, not only the nation, so that industry level we can match the industry level. So this is very important. So that's why you can the technology in tourism industry in 2022. One, because so many technologies are there, so many techniques are there, we need to use in our system. So that's why our project is like that. Where the project is already approved. So like that way, this is overall my future work, and this is my list of publication. You can see that. So already I have dispatched, I think, my list of publication. So this is my reference. So thank you. So kindly, if you have any questions, you can ask me. Sir, please.
So I request Radhakrishna sir, if you have any question, you can ask.
Yeah, thanks. Hi, Joy. Very good presentation. Good work. Can you hear me?
Yes, sir. I hear you.
Yeah. Yeah. The three works which you given is very good. Just I have some couple of aspects. When you consider the first one, the multi-tutor, right? So if you look at like around 25th slide or something, so that is like that itineraries are in sequence, or they are actually at random.
Yes, sir. It is based on sir. It It is sequence of itineraries, sir.
Sequence of
So,
itineraries, correct? Yeah, sequence of itineraries. That is in a particular sequence you are the person is traveling, correct?
yes, sir. Earlier, sequence of deploy was there, sir. But we have different sequence of itineraries. Inside itinerary, there is more than one deploys are there, sir. So like that way, our itinerary should be connected. One itinerary,
Your
suppose one.
your voice is breaking actually. Yeah, can you?
Yes, sir. Am I audible, sir?
Yeah.
So suppose the sequence of itinerary, suppose one itinerary today I recommend. So next day I need to recommend another itinerary, and these itineraries should be connected. So
Yeah.
that's
Okay. Yeah. No. Now my question is this one. So for normal recommendations, we use the precision recall and all those measures, correct? When it is a sequence of itineraries, so you should use the different evaluation measures. May not be the same evaluation measures as you normal recommendations are going on.
yes.
Right? The order, if suppose the order differs, suppose the itinerary 3 can be come in first and the itinerary 1 come later. So those things also may be good that if you can plan that.
Exactly, sir. Actually, sir, thank you, sir, for your kind information, sir. And also, sir, we have used our statistical test, some other tests also. There are some, I have heard some of the results here, sir. So, but I will definitely consider in future, sir. Thank you so much, sir.
Yeah. And the second one is you mentioned somewhere there is Monte Carlo technique that you are adopting it, right? So somewhere maybe you may be done that work, but if you highlight also how you modeled the data as part of the Monte Carlo things, it will be good actually.
Yes, sir.
If you can highlight, because you just mentioned a Monte Carlo technique you are using it, but your data was modeled, because usually in our recommended systems the modeling is more important. Right?
Okay, sir. Thank you.
So that is the second one. And third one is in the PWP algorithm, the second algorithm. You've shown that the hierarchy of interest, correct? Again, the point of interest is one, and again you have a local point of interest, correct?
Yes.
That's very good, but is it go as a hierarchical way of recommending it, or are you looking into that direction, or are you just simply a global versus local only?
Yes, sir. That global and local is some factor we have considered, sir. Some other factors is there in my mind, sir, that we are working right now. So we are also use some IoT devices, some IoT sensors use there that already sir published in IEEE Infocom that conference, sir. So that also we are doing, sir.
Okay. On my last question, last aspect is the 43 numbers, slide number 43. So the slide number 43.
Yes. This one, sir.
No, 43, 43. I think it's part of the PWP only, the second one. Yeah, here, somewhere here. Yeah. This one. Yeah. This one or previous one. Maybe somewhere you taken the interest and then the two parameters you are taking, the popularity, correct? And in these equations, at one of the equation, you didn't consider any weightage. At one place, you consider the weightage, and another place, you are not considering the weightage. Maybe just to go to the previous slide. Not this one. Somewhere you mentioned only just a straight away you taking the interest and the popularity measure. You are not taking any weightage for that. I didn't remember exact the slide number. You just go previous one. No, next. No, prior to one only. Somewhere it is there. You just in the interest of you're taking interest plus popularity. You're taken without any weightage. Just go. Okay, maybe. Yeah, maybe that weightage you didn't consider at one place. You considered in the first algorithm, but you didn't consider in the second one.
Okay.
Maybe some place it was there. Maybe just you can cross check that one.
Okay, I'll cross check definitely, sir.
Okay. Thanks. Yeah, very good presentation. Very nice work. Nice piece.
Thank you for presence here, sir. It is my honor. Thank you so much, sir. Thank you. Thank you.
Sir, now, sir,
only few things, Joella, in that presentation. The first I seen you selectively quiet. Few things you should look up and figure and all. Yes, should be corrected. And what is used? Deep learning concept you use? No, this future. Future. This is future work. Deep learning is LSTM. What is talk about data science? What is data science? Data science is the source of data and statistics.
This is the source of data set. We can see that Yahoo you can create it common. So hundreds millions of data sets are there. You can see Flickr photograph and videos are available. So their data sets are we are using here. We have city. Some other cities are already also there, sir. Due to some space limitation, I have only considered some of the cities. Then number of user, then POI attraction visit. You can see the size of the POI attraction visit.
Number they have taken randomly.
Yes. There can be a city because different city that number is different. It's based on the availability of signals. So then travel sequence. So this is my travel sequence, sir. That is our
So, Rotan sir, if you have any query.
Hello.
Yeah.
Joy,
Yeah. Audible, sir.
am I audible?
Yes, sir. You are audible, sir.
Yeah. I have nothing to say. Your hard work, your dedication, and the good research work is getting reflected in your publication. So there is no doubt that you have done excellent work. So I wish in this sense that you may submit your thesis as soon as possible. Okay.
Thank you, sir.
Okay. This much is from my side. Good. Very good.
Thank you.
Hollywood star is also there, Olaf star is also there, Vishal star is also there. So anybody, any question?
Nothing from my side.
Okay. So anybody else, any question?
Yeah, I have a question. In your second word, you have said that using EWP algorithm, you want to reduce the cost of travel. Minimum. So how will you want to use this algorithm to reduce that? I want to understand from your word.
Yes, very nice question. Actually, this is a very important factor that need to be considered in our algorithm. Not only in our algorithm, in future also, whenever it has budget and cost is most important factor. Okay, suppose our budget is 1,000 rupees. We need to complete our budget accordingly. Okay, we need to complete our itinerary accordingly. So your question is like that, as far as your concern, that how we use cost calculation in our algorithm.
Yeah.
Am I right?
You have said that you are using interest under interest. So it should be like that, the cost will be high in this case.
Now you can see that. Suppose a case like school, if you have visited school, suppose
Yeah.
temple is there and teacher there. So now we can calculate the physical distance from Puri temple to your beach. Suppose your physical distance is suppose for example 2 kilometers. Okay. So another place, suppose Pune temple, Pune is suppose 20 kilometers. Okay. So after that, our factor is like that. So based on that, my data set and longitude, the latitude and longitude we can calculate accordingly. Okay. Because every point has some latitude and longitude. Okay. And we have some Habermas formula for that. Okay. There we can do that in our agreement.
But my purpose of this question was, I am from West Bengal and I want to visit Puri. My main interest is for that temple. Okay. And then if I will go to Puri, then I will obviously visit beach. Then how it will reduce cost? My cost will be raising.
Yes, suppose you have 5 rupees cost, okay, 5 rupees. You have 10 rupees, there is 20 rupees, okay. But after 20 rupees, okay, you got is 25 rupees. So now, accordingly, within this 25 rupees, you need to recommend to the you need to provide it again within this 25. So now, if I go from temple to suppose beach, suppose your cost is 10 rupees, okay. Then temple to Pune, your cost is suppose 10 rupees. It is over 20, another 5 is less, okay. So after that, suppose you visit another place, then cost is 10 rupees. So at the time it comes, you can recommend this place because already your budget is exhausted. If I choose this point. So if I tell you that some places which is there like nearby, at that time cost is not reflected, but if it is far from this place, it is okay. Suppose Tripura is one place, you can consider. Suppose you know that suppose Kailasara, I forgot that name. Kailasara, some you can calculate the distance. So if I consider the distance, at that time maybe your budget is different. But on a very small distance, you can go by auto 5 rupees or 10 rupees, does not reflect. Because there is based on the traveling mode, what you choose. Okay, and some tourists are also there. Suppose now I am in Tripura, maybe I want to visit Delhi. Different tourists are also there. If you consider foreign people, they are like that. Today I am here, tomorrow I am in another place. Maybe it's different city. It does not bother them. They have a lot of funds. But our system should recommend. So like minimizing cost. Okay. So Delhi, so many places are there. So from here to Delhi, now which points I will consider? Which point I will consider? At that time, the points which I consider that need to be in my budget. So like that, people should be maintained accordingly. They need to reflect our ability.
In your husband, you have said that if I want to go to USA, then I will be with my family or any other person. Why?
If you go single, okay, just for personal life, then you can just.
And why are you considering other people?
Yes, you can consider multiple. If you are a personalized user, you can consider multiple. But users are there. Okay, suppose if you want to USA, yes. But if you only single person, then you can consider PWP is there, multiple is there. You can just keep on there. They will give you items. Okay? But some families are there. Maybe you have your mother. I want to tell them I want to go. Then what you do? You system can recommend at that time. So that's why at that time you can use our schedule.
Thank you.
So there is same name. So the reports here, in this case,
yes, that is also subject one because it is based on suppose same city, suppose 2 places are there. Okay, so name does not work there because we are taking the academics. So maybe they will comes under different category, maybe they will comes under different category. If it is the same category, then there is maximum identity. No problem. So has there any other question?
Okay, so thank you everyone. Rajesh sir, Rajesh sir.
Rajesh sir, you want to tell something, sir? Rajesh sir? Right. Yes.
Okay, so thank you all.
Rajesh here. Very good presentation, Jwala. And I wish you all the best. There are 2 questions from my side. First question that I have is basically the industry 4.0 that you have mentioned. Is it the IoT 4.0 you are matching with, or I was not able to understand? And my second question is the usage of deep learning in the recommendation engine. If you could tell us.
Yes, sir. Deep learning we considered in future, sir. So, am I correct, sir? Is it your question? Sir,
Yes,
deep
yes,
learning,
yes.
learning I will consider in my future work that already we are working, sir, like convolution neural network on that and RNN technique, LSTMs only are there. So based on that, we cannot directly use in our tourism industry. So there are some challenges are also there. So based on that, we are working. And as far as your first question is concerned, I will tell you that yes, obviously, industry 4.0 is very important factor here. We can consider it. We are also working on some IoT devices, some some IoT data, some humidity data, weather data, so that we can use in our algorithm. So that so weather data also. Suppose if I want to go a place where summer is there, okay. So there is no need to visit in winter place. Suppose as far as your interest level. So based on that, we can use our weather data. Okay, so that reflects our data, that our algorithm also. That's why we are using so many sensors are there already, so that we can utilize in our algorithm.
Okay.
Yes.
All the best.